Hello. In this video, we're going to discuss function notation and then we will evaluate some functions. So what we see here in this yellow box, f parenthesis x close parenthesis equals y. So this represents function notation, and this is read as f of x equals y, or the function value at x equals some number input is that y output. Essentially, function notation is just a fancy way to write y. So given this equation, y equals 3x plus 2, the equivalent function notation is f of x equals 3x plus 2. As you can see, all I did here was replace y with f of x. F of x means y, and when you see that or you're dealing with function notation, it's probably going to be helpful for you to write on your paper f of x equals y. That's kind of like your reminder of what you're looking at. So let's think about this conceptually before we delve into an example. What we're starting with here we have a graphed function. Now, we are given the graph of h of x. Generally, we write f of x because we want to say f for function, but a variable is a variable as long as you know what it means. So oftentimes we'll use f and then the following letter g, or maybe h. Maybe h represents height. In this example, it doesn't matter what that variable is. We're just using h instead of f. So example A, we need to find h of 2. H of x equals y. So that means we have x equals 2, and we need to find some output y. Well, where does x equal 2? X equals 2 at this ordered pair. And what is my output value? My output, or my y value, is 7/2. So 7/2 represents the answer here. Let's do this again. H of x equals y. So this says we have an x is equal to 5. So we go over to our graph. Where's x equal to 5? X is equal to 5 at the ordered pair 5, -1. So the output, or the answer here, is going to be h of 5 is equal to -1. We could even go further, and I could expand on this question. This third piece that I have added in here says, for what value or values of x does f of x equal -1? Remember, f of x is equal to y. So this -1 represents a y value. And if we go and look at our graph, we have two x's that correspond to y equals -1. This would be x equals 1, as well as x equals 5. Let's look at another example. In this example, we are given a function g. G of x is equal to x squared minus x plus 7. So this is a quadratic function. Again, we'll talk more about quadratic in the future, but the function is noted as g. Remember, we can use any letter to represent the functions. It could be q of x, q of t, h of p. The variables don't matter, but it's that, understanding what we're looking at. And so here we have g of x. G is a function of the independent variable x, and my output is found by plugging my input x into these variables. So for example 1, we are asked to find g of 0. That means g of x, this means we're letting x equal to 0. So g of 0 is 0 squared minus 0 plus 7. And simplifying the right side of that equation, we get that g of 0 equals 7. So that would be our answer, 7. All right, let's try this again with g of negative 3. Remember, g of x, that means x is negative 3. So g of negative 3 equals negative 3 squared minus negative 3 plus 7. Wherever I had an x in my original given function, I plugged in the input negative 3. Now, what's very important here is you guys all note that I used parentheses. I didn't have to use them so much with 0, but when you're plugging in a negative, it's going to be specifically important. Or especially if, looking at example 3 here, we've got x minus 5. We're plugging an expression into the variable. All right, so making sure we use parentheses, negative 3 quantity squared, that quantity negative 3 squared, that gives me negative 3 times negative 3, which is 9. I like to point this out because, we all know that when we square a number, it's going to be positive. And I've had students come up to me and say, well, I know that it's going to give me this number, but the calculator is giving me a different number. So for example, if you typed negative 3 squared into the calculator like this, that is negative, and the calculator only squares the 3. So we have 3 times 3, we get negative 9. All right, so the parentheses are really important, and I just like to point that out very early on in the semester. So this gives me a positive 9 minus negative 3, that's plus 3 plus 7. Here we can determine that g of negative 3 is 19. All right, let's look at 1/3 example. I pulled that function back down so we'd have more space to look at this. We have g of x equals x squared minus x plus 7. And here we're asked to evaluate or determine what g of x minus 5 is. So we are plugging x minus 5 in wherever there is an x value. So the way this would look, this would be g of, I'm going to rewrite that x as x minus 5 equals this quantity. Instead of x, I have x minus 5 squared minus, again, instead of x, I have x minus 5. And then we write our plus 7. So it's very important that you take a moment and make sure you understand what I wrote out here. All right, so we've got g of this x minus 5 function. We get this quantity, x minus 5 squared. And then we have x minus 5 with a minus in front of it. That's going to involve some distribution. Simplifying this, g of x minus 5, if we look at x minus 5 squared, that means x minus 5 times x minus 5, and I'll need to FOIL that. Minus x minus 5, that's the same as minus x. Distributing that negative, we have plus 5 and then plus 7. So g of x minus 5 equals x squared minus 10x plus 25 when I FOIL. I still have that minus x, and I can add the 5 and the 7. That will give me a plus 12. Combining like terms, I have x squared minus 10 minus x. That's minus 11x. And then we have plus 37. And that's our final answer for evaluating this function. So just to recap, we talked about evaluating a function with both a number and an expression. We talked about this conceptual idea of a function and remembering the fact that f of x equals y. So that kind of recaps our function notation and evaluating a function videos. As always, if you have any questions, comments, or concerns, please email me.